Welcome to the 8th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss the difference between scalar and vector quantities. To describe events in nature, we use physical quantities. There are many different quantities that we use, but we can form two big groups of them. Some quantities do not have a direction. We call these scalars. Other quantities cannot be understood without a direction. We call these vectors. This distinction will be very important later on because we will need to treat these two kinds of quantities very differently. Now let's see a couple of examples of both. Scalars only need a number and a unit. Think about mass, temperature, time, energy, etc. It wouldn't even make sense if we tried to add a direction to these. For example, if I said the temperature here is 30 degrees Celsius to the left, that would be completely meaningless. On the other hand, vectors need both a magnitude and a direction. So we have to specify how much and also in which way, in which direction. For example, velocity, force, acceleration, or the electric field are all vector quantities. For these, as we said, we need to specify the direction. If I told you that a car is moving at 50 kilometers per hour and I asked you where it will be in an hour, you couldn't tell unless I told you the direction of the travel. Let's take another example. In the tug of war or rope pulling, two teams are pulling the rope from opposite sides. For each team member, I can specify their force vectors. If the team on the left pulls to the left and the team on the right pulls to the right, it is a very interesting game to see which team is stronger. But if all the force vectors act in the same direction, then there is no game anymore. Then it's just a couple of people carrying a rope. In physics problems, vectors are usually represented by arrows. The arrow has a starting point. In the case of a force vector, for example, this is the point at which the force acts. The length of the arrow represents the magnitude of the vector, while the direction of the arrow shows the direction of the vector. Finally, we have to mention vectors in 3 dimensions. We live in a 3-dimensional world, so vector quantities exist in 3 dimensions. We can decompose any 3D vector as the sum of 3 vectors, each lying along one of the 3 coordinate axes, so x, y, and z coordinate axes. Then we can study each of the 3 vectors independently of the others. This is what we do, for example, when we decompose a force into its components, which are perpendicular to each other. But for now, we will restrict ourselves to studying vectors in only 1 dimension, and we will deal with the more complicated situations later. Thank you for your attention and see you in the next video.